Ladies and gentlemen, we're going to start with the perfect table, and what you need to do is you need to fill out as much of this perfect table as you can. Yeah, you can use a calculator. I would stop, like squares is not going to get to 1,000, but once you get to an answer that has 1,000 in it, stop. Okay, in that column, and then move to the next column. Okay, so you're just plugging in, you're doing 1 squared, and then 1 cubed, and 1 to the 4th, 1 to the 5th, 1 to the 6th. Off you go. If you haven't finished, that's what you should have in your perfect table.
Why are some of them red?
Just because I need to add them. This one's 256. Hard to see it. All right. A little blurry. But. Okay. Yeah, that's okay. All right, very good. You're going to use this table as we go through today's material. I want you to look at page 175 of your student journal. I'm not going to use a calculator right this minute, no. $175, student journal. Okay, can I have your attention up here, please?
Not everything else, but
175. Hey, gentlemen, ladies, attention up here. Okay, in your own words, write the meaning of each vocab term. I'll let you do that in a while on your own if you'd like. It's a good way to review, but we're going to talk about radical, index of a radical, nth root of a number. Okay, some of that is defined down here. These are the two that I really want you to focus in on and make sure you get those vocab terms as we go through today. Okay, so I want you to take a look at page 176. On page 176, we're going to go ahead and talk about how to do these types of problems and what they're asking you to do as you go through this extra practice here. So find the indicated real nth root of A. So when it's saying nth root of A, they're telling you what A is here. A is 64. So if I'm dealing with the number 64 and I want to find the nth root of it, they're asking you to take A, put it inside a radical, and then find, in this case, the second root of it. Now you in the past have only called the second root square root. The reason why I'm calling it the second root right now, and I'll go back to calling it square root, is because when you get over to this one, say number 2, it's now telling you that A is 27, and you're finding the third root. Okay, so let's understand what they're saying here. This says, what number times itself twice will make 64? Okay, and you guys know the square root of 64 is 8. 8 times 8 makes 64. Well, this is saying what number times itself 3 times makes 27. Good. Now, if you don't know that, you have your cool, handy-dandy cheat sheet there that you made today. And if you look at your perfect cubes, you say, hey, cubed root, if I want to get to 27, whoa, there's 27 in my cubed roots. Okay, oops, 27 in my cubed roots there. That's 3. X is 3. Okay, so this is 3. What's that? We'll get to that. Okay, so really when we're looking at this general form here, they're saying, not saying that, okay? They're saying A to the power of n. Okay, that's what they're using in this. So when we had our notes here, we talked the nth root of A, that's what we're referencing right there. Okay? A to the power of n. Or excuse me, A to the root of n. Not to the power of n. Okay? The nth root of A there. So when I'm taking the nth root of A here, I'm taking 256 and I'm finding the fourth root of it. So once again, using your table that you've already done, if you said, well, 1 times 1 times 1, 4 times is 1. 2 times 2 times 2 times 2 times 2. There, 2 to the third, or excuse me, 3 to the fourth is 81. 4 to the fourth is 256. Well, that's what I want here. 4 times itself 4 times makes 256. This answer is 4. Okay, there's one other little piece you need to know. You started this problem without a square root or without a radicand. Okay, this little symbol is called a radicand. You started it without that radical symbol. All these problems you started without it. When you impose a radical, if it's an even number root, you have to put a positive and negative sign out here. If it's an odd number root, that's not going to matter. But if it's an even, you need to put a plus and minus. That means your answer could be positive or negative. So you have two different answers. You have positive 8. This means positive 8. And you have an answer of negative 8. And this means positive 4 and an answer of negative 4. Okay? Why don't you put a positive negative here, and how come you have to put it on these? Okay? Talk to your neighbor about it. Prove why you have to or why you don't have to in terms of number 2 there. Okay, why do I have to? Oh, I guess we're done. I guess our lesson's over. Uh-oh. That's not good. Yeah, you have to because positive 8 times positive 8 is 64 and negative 8 times negative 8 is 64. Here, positive 4 times positive 4, positive times positive is positive, times positive is positive, times positive again is positive. Now if I go, if I do that, negative times itself 4 times, negative is positive, times negative is negative, times negative is positive. Okay? So you have to use both plus and minus. Why don't you have to put plus minus here? Yeah? So positive 3 times positive 3 times positive 3 is 27, right? Okay, so go the other route. What's that? It's negative 27. That's not true. So if it's an odd index, this is called your index number. Remember those terms. Index of a radical. Okay, from your previous page, that's your index. If it's an odd index, you just take and put the positive, or if it's a negative number in here, you put the negative. Okay, but you don't put both. If it's even, you have to put both. And that's why. Okay. Let's take a look at 7, 8, and actually go ahead 4, 5, and 6. Finish those 3 up. Make sure you put the correct plus minus if you need it. Okay, use your table there. All right, number 4. What's the fifth root of 243? That is 3. Do I need plus minus? No, why not? Good, it's odd. Okay? 256. 8th root of 256 is 2. Do I need plus minus? How come? It's even. All right. Very good. And 10,000. That's a lot. 4th root of 10,000? 10. Do we need plus minus? Yes. Got an even index there. Very well done. Okay. Any questions there? Hey guys, I'm going to tell you. Hey, yes, Sarah? Okay, now on number 5, you're taking the 8th root. You have to actually, we didn't actually, on our table here, we didn't go out to the 8th root, right? So if you have a calculator, go ahead and grab your calculator real quick. Hey, on your calculator, on your calculator, if you want to do the 8th root of 256, now it's not going to give you the plus minus, it's just going to give you the positive number. But the 8th root of it, you're going to type in 8, and then you're going to go to the button that says Math, and you are going to select option 5. That has a little radical symbol with an X up there. Okay? And in most of your calculators, it's going to put that 8 up in the index. Some of them it won't. It'll just say 8, and then it'll say X root. Okay, and then you put the 256 in and hit enter, and that'll give you 2. That's how you do those roots on your calculator. Okay? So if you want to know how to do that for like assignments and tests and future reference, you probably should write it down. Okay, put the index in, hit Math, option 5, which is your X there. Oops, and you have to actually put some number in there. And hit it. All right, so that may be a beneficial piece when you're actually doing these. Okay? But right now, using either your calculator or your table, I want you to evaluate these numbers. Number 7, 8, 9, and 10. And then give number 11 a go. Okay? 7, 8, 9, and 10. Okay, what's 4th root of 625? Good. Now that we've talked about the plus minus, usually the rule we follow in math is if you start the problem, like we did up here on number 1, we actually started that problem without any radicand, so without any square root little symbol. If you start the problem and at some point during the problem you actually have to write that square root symbol, or you have to take the square root or the 4th root or the 6th root, then you have to put a plus minus answer. If you start the problem and they already have the symbol in it, then it's okay to just assume they only want the positive answer. Okay? We understand that? Now, with that being said, if you put plus minus 5, I'm completely fine with that. Okay? In this one, is it plus minus? No. No. What is it? Negative 8. And here? Okay, here? Negative 3.
No. Number
11
is 3.
Okay. Hey, how did we do this one? First of all, you're raising it to a power. Shouldn't it get bigger?
No.
Why isn't it going to get bigger? It's a fraction. You guys, this fraction right here, this is a new symbol for you. Most of you. This is 729. This actually means 729. And that, anytime you have a denominator, that is actually that number. Okay? That is the 6th root of 729. So if you actually, on your calculator, if you typed in, if you did 6, math, option 5, and put 729, that gives you that. And it's the same thing as if you did 729 raised to the 1/6 power. You get the same thing. Those are the same answers. They mean the same thing.
I like the second way. You don't have to
That's tough, too. Okay, so this one is actually saying the square root of negative 81. So what number times itself is negative 81? Negative 9? Negative 9 times negative 9 is it's positive 81. How about positive 9? Positive 9 times positive 9 is 81. Can I multiply a number by itself and get a negative? No. If you're taking an even root, you can't have a negative number in here. This is no real solution. No real soul, man. An even root cannot equal a negative. If you have an even number there, it cannot equal a negative. That's bad. We frown on it. All those bad things. Okay? All right, go ahead and turn the page, please. Take a look at the top of the next page. Doing a few rewriting. Rewrite the expression in rational exponent form. In other words, use a fraction to write that. Rather than writing it like in radical form, write that 4 with a fraction up here. What fraction goes up there? Talk with your groupies about it. Okay, what is it?
It's 4 to the power of 3/5.
Hey, the bottom is 5. Okay, now you can write the other way. If I put a 1 there, I have to raise all that to the third. Like that. The other way to write it is 4 to the 3/5 power, because then you can bring the 3 in. Either way will work. If you want to go like that, that's fine. If you want to go like that, that's fine. They both mean the same thing. Okay? So this one right here would be, whoops. Okay, now notice when I put -8 there, and I go to the 1/3, and then square that. Remember, I've got to put the negative in parentheses if it's a negative power. You're going to write it like that. You have to put that in parentheses. If you just want to write it like this, that's fine as well. Yes, Logan?
So, for number 13, why wouldn't it be plus minus 4 and this?
It's not a plus minus. This is an odd root. And we're not evaluating. We're just rewriting it, right?
Yeah.
So we're not evaluating. Even if it was an even root, like on number 15, we're not going to put plus minus because all we're doing is rewriting it in fraction form. We're not solving. Correct. Yes, Sarah? Well, that just means you have to raise the whole thing to the negative power when you have that negative number in. Or, excuse me, to the 1/3 power. Okay, if you don't put parentheses around, if you write it like that, you're only raising the 8 to the 1/3 power.
Then it's -1.
Yeah, you got to. All right, you got to put parentheses around it. Okay, so 15 to the 7/4. You don't have to have the parentheses on that. All right, I want you to rewrite 16 through 18 in radical form. Totally radical, man. Of attention, so and move on here. So hopefully you've got this. We've got 5, we got -3, and you could square it like that, or you could write it like that. You don't need the parentheses if you write it the top way. You don't need this set of parentheses. You could erase those. Either one of those would work. Okay? I would probably start by writing it in this format. It's going to help you in the long run to do these in your head. Oops, not 12. Unbelievable. That's a 4. Okay, last piece, number 19 and number 22. Evaluate the expressions. Okay, we're going to do those together. So, first thing I'm going to do is I'm going to write it in this format. And I don't want to use a calculator on this one. Okay, what's the 5th root of 32? So start trying to, 1 times 1, obviously 1 is just 1. How about 2 times 2 times 2 times 2 times 2? Good, so the 5th root of 32 is 2, and then square it, we get 4. That's our answer. Okay, so write it in radical form, or in this form first, makes it a little easier. 256, we're taking the 8th root of it and then raising it to the 7th power. Yeah. Like here. the bottom number always is your index here. Okay, so the 8th root of 256 also happens to be 2. And 2 to the 7th is 128. Okay, while I'm handing out your assignment, I want you to complete those next 4 problems. Then number 25 is a challenge one you can complete as well, if you'd like. There are the answers. Check your work.
Yeah.
Remember, number 20, you can't take an even root of a negative number, therefore it's no solution. Number 21, writing in that format. Now I actually put the squared in there, but gives you 49. Number 23, notice that negative is not included. It's like having a negative 1 on the outside, so that just gets tacked on at the end. Okay, you'd have to have parentheses around that 729 for the negative to be included. Once again, number 24, you cannot take a root of a negative, or an even root of a negative, therefore it's no solution. If you did the challenge problem, there it is. Just plugging in 14 or 1,493 in for A and solving.